So this is my physics final project called The Physics Behind Hitting a Home Run. For some background information, in baseball the term home run is used when the offensive player hits the ball over the fence. This is extremely difficult as the fence is at least 300 feet away, which is really far. As you can see on the graphic on the right, this depends though because every stadium has a different length fence, so it varies. In the baseball world, because the fence is so far away, the players that hit the most home runs are seen as the strongest players, but as we will discuss, there are actually many factors that determine how far a batted ball travels other than just strength. So my interest in this um, is because I played baseball for many years, and I was always told that you just got to be strong to hit home runs. But it's important to see that there are actually many other aspects that go into this, and if you understand the physics, you actually might be better off in trying to hit home runs because you know it's not all just about strength. So one of these impacting factors is the launch angle. There's actually been plenty of research done here, and it has been determined that the optimal launch angle for a home run is about 25 to 35 degrees. So I decided to do a little experiment to test this, and I took a slow motion video of a baseball player hitting a home run and did a tracker analysis to find the angle of that home run, and I found an angle of 27.42 degrees, which is consistent with the research that has been done being between 25 and 35 degrees. But there are also many other factors that affect the distance traveled of a baseball. One of the big players is the momentum of the bat and the ball. The momentum of this system can be determined by adding the momentum of the baseball bat and the baseball. So obviously, if you increase either one of these, the resulting momentum of the ball after the collision is going to be greater, which means it will have a greater velocity, which means it will end up traveling farther. Another big thing is the spin of the baseball. It has to have the right amount of backspin. Too much backspin and it'll go straight up in the air and not travel far enough. Too little, or if it has topspin rather, then it will just dive right into the ground and not travel far enough. Another is the air density, which can be impacted by the elevation and the air temperature. Baseball stadiums at higher elevations have less air density, so there's less resistance of the ball, which means it goes farther. And also, stadiums in warmer areas that have higher temperatures will also have a lower air density as a result of this, and there will be less resistive force, which means the ball goes faster or farther. Here are my physics models. I have the system schema and the force diagram with respect to the ball. And there's some really cool real world applications here. As you can see in the GIF, there's this thing called HitTrax, which there's a bunch of sensors in the batting cage, and you can actually hit baseballs indoors. And using it will the computer that's hooked up to the system will make a bunch of calculations based on the factors that I talked about, and will actually give you a visual representation of where your ball travels or how far it travels, and it'll show you that on a screen. So that's pretty cool. And here are my references.